Hello friends, I welcome you in lecture number 5 on Taylor and Maclaurin series. In this lecture, we will discuss this question on Maclaurin series. This question was asked in GTU Winter 2016 exam. We know that Maclaurin series is Taylor series of function fx at x equal to 0, and Maclaurin series of function fx is given by f of 0 plus f dash 0 times x plus f double dash 0 divided by 2 factorial times x square, and third derivative at 0 divided by 3 factorial times x cube, and so on. So to obtain the Maclaurin series of function, we have to compute derivatives of function at x equal to 0. So first we denote given function by log 1 plus x. So let fx equal to log of 1 plus x. Given function is logarithm of 1 plus x to the base e, and we have to find out value of function f at 0, that is log of 1 base e, and we know that log 1 base e is 0. Now we compute first derivative. Derivative of log x is 1 by x. Instead of 1 by x, here we will have 1 over 1 plus x. Therefore first derivative at 0 is 1 divided by 1 plus 0, that is equal to 1. Then second derivative at any point x, derivative of 1 over 1 plus x is minus 1 divided by 1 plus x whole square into derivative of 1 plus x, which is 1. So this is minus 1 divided by 1 plus x whole square. Therefore second derivative at x equal to 0 is, we substitute x equal to 0 here, so this is going to be 1 plus 0, that is 1, and square of 1 is 1. So second derivative at 0 is minus 1. Then we differentiate again to obtain the third derivative, derivative of this quantity. So we know that derivative of 1 by x square is minus 2 by x cube. Instead of x, here we have 1 plus x, and here this minus 1 into minus 2 is equal to 2. So we have 2 divided by 1 plus x cube, and if we take x equal to 0, this denominator will be 1 plus 0 raised to 3, that is 1. So third derivative at 0 is 2, and so on. So this is enough. If we go up to third derivative, we will obtain 3 non-zero terms. So we can go for higher derivatives also to obtain the few non-zero terms. For suppose I consider fourth derivative at x, then it is 2 as it is. Derivative of 1 over 1 plus x cube is minus 3 divided by 1 plus x to the power 4. So this is equal to minus 6 divided by 1 plus x to the power 4, and if we take x equal to 0, we will obtain minus 6. We obtain one more derivative, and that is derivative of fifth order derivative at any point x. This is equal to derivative of this function. So minus 6 constant as it is. Derivative of 1 over 1 plus x raised to 4 is minus 4 divided by 1 plus x to the power 5, and this is going to be 24 divided by 1 plus x to the power 5, and we require value of this derivative at x equal to 0. For x equal to 0, here we have 1 plus 0, that is 1 to the power 5. So fifth derivative is 24 at x equal to 0. So we have obtained derivatives up to fifth order and I think this is enough for our Maclaurin series. So now we write down Maclaurin series for log of 1 plus x. Before that we write down the formula. So now let me choose another color. Now we write that Maclaurin series formula. Maclaurin series of function fx is, we have to write down terms up to x raised to 5 because we have obtained the derivatives up to x raised to 5. Second term is f dash 0 into x. Third term is second derivative at 0 divided by 2 factorial times x square. Third derivative at 0 divided by 3 factorials times x cube. Fourth derivative at 0 divided by 4 factorial times x raised to 4 plus fifth derivative at 0 divided by 5 factorial times x raised to 5 and so on. Now we substitute values of all these derivatives. Therefore our function fx is, value of function f at 0 is 0, first derivative at 0 is 1, second derivative is minus 1. So this is 1, so here we have plus x, second derivative is minus 1, so we have minus 1 half times x square, 2 factorial is 2. Third derivative is 2 and fourth derivative is minus 6. Third derivative is 2, so we have 2 divided by 3 factorial, that is 6, and fourth derivative at 0 is minus 6, so this we replace by minus 6, and 4 factorial is 24 x raised to 5. Fifth derivative at 0 is 24, so here we have 24 and I write 5 factorial as 5 into 4 factorial times x raised to 5 and so on. So you can see the pattern here. I obtain alternately positive and negative terms, so I can imagine further terms also. Now our function is log of 1 plus x to the base e, and we simplify all these terms. This I can rewrite as minus x square by 2. Here 2 will cancel out and we have x cube by 3. Here 6 will cancel out and we have x raised to 4 by 4 plus, and 4 factorial is 24, that will cancel out with this 24 and we obtain this Maclaurin series of log 1 plus x. So this is the Maclaurin series of log 1 plus x, and we assume that this equality holds for those values of x for which the series on the right hand side is convergent to this function. So with that assumption I have written equality here. So we always keep in mind that whatever series we obtain, it is not necessary that it will be convergent to given function for all values of x. So this is the Maclaurin series of log 1 plus x, and that is the first part of the question. Obtain the Maclaurin series of log 1 plus x. In the second part we have to obtain the series of log 1 plus x divided by 1 minus x. We are asked to obtain the Maclaurin series of 1 plus x by 1 minus x. So we know that this is the function log 1 plus x minus log 1 minus x. Using the property of logarithmic function, we can write log 1 plus x by 1 minus x as difference of log 1 plus x and log 1 minus x. Now we have obtained the Maclaurin series of this log 1 plus x. So using that Maclaurin series, we can write the Maclaurin series of log 1 minus x, and then we will take the difference of these two series. So in the next step we write down the Maclaurin series of log 1 minus x. For that we replace x by minus x in this series 1, and we get the Maclaurin series of log of 1 minus x. Log of 1 minus x to the base e. This I can rewrite as log of 1 plus minus x to the base e, and therefore if I compare with this, I obtain that instead of x I have minus x here. So here on the right hand side I have to replace x by minus x. So here minus x as it is, square of minus x is x square, so we write x square. Cube of minus x is minus x cube, so here we will have negative sign. Similarly, fourth power of minus x is x raised to 4, so here we have minus x raised to 4 by 4, and fifth power of minus x is minus x raised to 5. So we obtain negative sign for each term of the Maclaurin series of log 1 minus x. So we can easily obtain the Maclaurin series of log 1 minus x simply by replacing x by x in the Maclaurin series of log 1 plus x, and we give this number 2. And now we obtain the Maclaurin series of log 1 plus x divided by 1 minus x to the base e. This is using the property of logarithm, log 1 plus x to the base e minus log 1 minus x to the base e. So we have to add these two series on the right hand side of 1 and 2. So we can directly add, or we can write the series here. Maclaurin series of log 1 plus x is alternately positive and negative. X minus x square by 2 plus x cube by 3 minus x raised to 4 by 4 plus x raised to 5 by 5, and so on. And negative of log 1 minus x. So here every term is negative in this series. So if we take multiplication by minus 1, all the terms will be positive. So that we can directly write by taking negative sign inside. We have all the terms as having positive sign. X plus x square by 2 plus x cube by 3 plus x raised to 4 by 4 plus x raised to 5 by 5, and so on. So this we are multiplying by minus 1, and we obtain this series. So now we can easily add corresponding terms. X is added to x, and we have 2 times x. This x square by 2 will cancel out, and we have 2 times x cube by 3 plus this term will cancel out, and this is going to be 2 times x raised to 5 by 5, and so on. And we can take 2 common, so we have 2 times x plus x cube by 3 plus x raised to 5 by 5, and so on. So this is the series of log 1 plus x divided by 1 minus x to the base e, and we give this number 3. So this is another second portion of the question. First we have obtained the Maclaurin series of log 1 plus x. Using that Maclaurin series we obtain the series of log 1 plus x by 1 minus x, and using this we have to find the approximate value of log of 11 by 9. So the last part of the question is using this series number 3 we have to obtain log of 11 by 9. So I have to select particular value of x for which this is going to be equal to 11 by 9. So we can compare with 1 plus x by 1 minus x with 11 by 9, and we can decide the value of x. So if you cross multiply, you will have 9 plus 9x equal to 11 minus 11x, and if we take this on this side, 9x plus 11x will be equal to 11 minus 9. So 11 plus 9x is 20x, and this is going to be 2. So x is equal to 1 by 10. So if we take x equal to 1 by 10, we will obtain log 11 by 9 on the right hand side. So now we can obtain the value of log 11 by 9 for this value of x. For x equal to 1 by 10 in this series 3, we will obtain the approximate value of log 11 by 9. So now in the next step, we consider x equal to 1 by 10 in this series. So let me remove this. Now putting x equal to 1 by 10, putting x equal to 1 by 10 in series 3, we get, here we write one more step, log 1 plus 1 by 10 divided by 1 minus 1 by 10 to the base e. This is equal to 2. X is replaced by 1 by 10. So here we have 1 by 10 to the power 3 plus 1 by 5, 1 by 10 to the power 5, and so on. So we are using only 3 terms of this series on the right hand side, but you can see we are considering x equal to 0.1. So if we take higher powers of x, then they are going near to 0. So it is enough that we approximate by 3 or 4 non-zero terms, because higher powers of x will tend to 0 for x equal to 0.1. So this will give us sufficiently nearly equal to value to the exact value. So this is if I take LCM, I will have 10 plus 1, that is 11 by 10, and here I will have 10 minus 1, that is 9 by 10, and 10 will cancel out. And if we use scientific calculator, and if we calculate all these things, we obtain that approximate value of log 11 by 9 up to 5 decimal places is 0.20067. This I have calculated using my scientific calculator. So in this way we can obtain the approximate value using Maclaurin series, approximate value of this type of logarithms using this type of Maclaurin series. So this is a nice application of Maclaurin series, and here I have written approximate sign because we are not using all the terms of the series, but whatever value we will obtain, this approximate value will be nearly equal to the exact value. So this approximation will be good enough for exact value of log 11 by 9. You can check using your scientific calculator. You can find out the value of log 11 by 9, and you can see you will obtain up to 5 decimal places, you will obtain the same value. So this is all about this session. In this session we have discussed this question which was asked in GTU Winter 2016 exam. We have obtained Maclaurin series of log 1 plus x Using that series, we obtain the series of log 1 plus x by 1 minus x, and by taking x equal to 1 by 10, we obtain approximate value of log 11 by 9. So I stop here. Thank you.